Hello. We are starting on the units that involve voting math and then apportionment math. If you are in my classes in fall 2020, this is actually very timely. Many of us are casting our mail-in and early votes up through election day, which is coming up very soon at the time of me recording this. So this should be interesting to see what happens. So, but in this unit, we're going to first look at some of the different popular voting methods and how the math behind those work as far as trying to decide on winners. And then we're going to look at apportionment methods, and that comes into play more with things like our census. Probably had all of you should have by now have completed your household census. And that information can help when deciding how to apportion representatives for your state and for deciding on certain things with funding, because they need to know how many people there are. But there's different apportionment methods when you're trying to divide things up fairly. And we're going to look at those too. But that'll be the latter half of this. Okay, so getting into voting first. We're going to look at first some very popular voting methods in this immediate lesson. And there's 4 popular ones that you probably are familiar with. Plurality method, that's the one where you cast the most, whoever casts the most gets the most votes wins. The board count method, this one you end up using some rankings. Plurality with elimination method is an offshoot of the plurality method. And the pairwise comparison method also uses rankings, but in a different way than board count. So we'll look at each of those and look at an example. Now, before we look at those methods, just want to mention that the results of an election can be organized or summarized into something called a preference table. When people arrange your choices in order of preference, the table can help show how many people chose each outcome. So it can summarize things and make it easier to analyze and decide who's the winner. An example of a preference table. You might have something like, you might have, across the top, it might have number of votes. And then you might say, okay, you might list the first place vote, second place vote, third place vote. And let's say you're trying to vote between A, B, or C. So you might have, out of the people that cast votes, you might have 8 people that voted for B first, A second, and C third. You might have 12 people that voted for A first, C second, B third. You might have 3 people that voted C first, B second, A, and so on. So you can make this table that summarizes how many ranked their votes in what ways, by first, second, and third place choices. So that's just called a preference table. So in your work, you're going to see preference tables, and then you're going to have to use them to apply these voting methods. Okay, so first voting method, probably the one you started using the earliest in your lives. Everybody votes, and whoever gets the most votes wins. This one's commonly used when you're a little kid, like on the playground or in a classroom or somewhere. Typically, you vote for one candidate, and the candidate with the most votes wins. If you decide to use a ranked vote, you're just looking at the first place votes and seeing who got the most first place votes in the rankings. The winner does not necessarily have to have a majority of votes. Majority means you have over half the votes. Supermajority can be even a different number. Like often a supermajority has to do with 2/3 of the votes. So having 67% of the votes. But in a strict plurality, it doesn't have to be majority or supermajority or anything like that. It just needs to be over half the votes. Most common used method when more than 2 candidates are running for something. Like if you have a particular position and you have 5 people running for it, this is commonly the type of method you would use. Some specific uses I listed there include choosing Oscar winners, choosing U.S. Congress members, and also in Canada, choosing their parliament members. All right, so let's look at an example of plurality method. Let's say that you have a vote being cast and you have people ranking first, second, and third place. And you have two people, like I'll just use initials because let's say that we have initials F, G, and Y for the things we're voting for. We have two people that voted F first, G second, Y third. We have one person that voted G first, Y second, F third. And then we have four people that voted Y first, F second, G third. So this is our preference table here. So you got two people that voted FGY, one person that voted GYF, four people that voted YFG. So if we're using plurality method, we just need to look at the first place votes. So first place votes, F had 2, G had 1, Y had 4. Since Y had the most, Y wins plurality. And there were 7 votes cast, because 2 plus 1 plus 4 up there is 7 votes. So it turns out Y not only has plurality, but does have the simple majority too. Because half of 7 is 3.5. So if you have over half, then you, like having 4 is over half. So Y not has plurality just simply by having the most, but also has the simple majority by having over half. Doesn't always work that way. Sometimes you can have plurality without having the majority. All right, another method, this one gets a little more involved, is called the board account method. This one involves rankings. Those of you who are football fans, the board account method is what they use for figuring out the winners for the Heisman Trophy. You have everybody rank the candidates from most to least favorable. The each time a candidate is voted least favorable, they get 1 point. Next to least favorable, 2 points. Next one up from that, 3 points, and so on until you get to like your highest ranking. And then you add up the points. The candidate with the highest sum of the points is the winner. And this method is named for Jean-Charles Desbordes. He was a Frenchman. You'd call him a polymath. He wrote on a variety of subjects, including math, physics, science, experiments, voting theory. He was pretty well rounded with his math and science. But it's called the board account. So let's go back to the chart I made a few minutes ago where we were talking about the plurality method. And let me rewrite the chart here so we have it. We had first, second, third place votes. And we had 2 people that voted FGY. We had 1 person that voted GYF. And we had 4 people that voted YFG. All right, so let's do this. I like to list the different candidates. So I'll list FGY, and then I like to deal with their. So in this case, we have third place votes, third place points. We have second place points, and then we have first place points to deal with. All right. So third place is going to get 1 point each. Second place is going to get 2. The higher you are, the more points you get. First place will get 3. I like to start with third place because I know that one has to be 1 point. And then I just count up. Okay. So F had 1 person vote and put F in third place. So 1 times 1. So across the bottom there, the third place voters. G had 4 that voted last place for that one. And then Y had 2 that voted it into last place. Then second place, see G had 2 that voted in second place. So looking across the second place row there. Y had 1 that voted in second place. And then F had 4. Then first place, F had 2. G had 1, and Y had 4. So we could take how many votes it had for each place, multiply by those points, and then add up the point totals. And that'll tell us where we're at with our winner, chicken dinner. So we have, for F, we have 1 plus 8 plus 6, which is 15. For G, we have 4 plus 4 plus 3, which is 11. And then for Y, we have 2 plus 2 plus 12, which is 16. All right, so who has the most points? Y has the most points. And wins. Woohoo! So in this case, under this method, Y gets selected. And it turned out that Y was also the winner when we were looking at plurality method, and Y is the simple majority winner too. It doesn't always work out that way. You can have somebody who wins, you can have an option that wins one method, but that doesn't win another voting method. And that's kind of a issue that we'll talk about a little later. But in this case, Y consistently has been winning. Lucky Y. But yeah, so I started with 1 point for each third place vote, 2 points for each second place vote, 3 points for each first place vote, and then added up all the points to see who had the most. And that was Y with 16. All right, an offshoot of plurality is one called the plurality with elimination method. This one is also known as the Hare system because of its creator, Thomas Hare. So Hare spelled the same way as rabbit, hare, H-A-R-E, but it's for a person. And in this one, each voter is supposed to get one choice. The majority wins. If there is no majority, then the candidate with the fewest votes is eliminated and another election is held. So you must have a majority. You must have over half the votes. So it's like plurality, but it has that majority requirement. And if nobody has the majority, then we eliminate the one with the fewest votes and do this again, hold another election. If there's still no majority, repeat the process until there is one. We're not going to actually hold new elections in our word problems. We're going to just use the ranking chart and the preference table, and we're going to eliminate the one that had the fewest votes, and then in our preference tables, that'll bump things up, and then we'll recount the votes using the preferences. So I know the slide says that usually this is a one vote cast kind of deal, but that's not practical for our homework problems in a lot of cases. So we're going to be using the preference table in a way to like do a multiple voting. So one of the disadvantages is that possible need for multiple elections. You can think about, like, if we were trying to do this for President of the United States, that could be a real issue. Because how many people who voted the first time might not be able to vote the second time, or vice versa. It's a lot of time and effort and money. So that's too large of a scale of a voting situation to do something like this. Something smaller, though, it might be fine. Sometimes, like, you might do like a combination of voting methods. You might do a runoff election, or you might do a mix of this method and board a count to help limit the number of elections you actually have to hold. So sometimes you can be creative. The key you're going to find is that you've got multiple options for tallying votes. You just have to agree ahead of time which one you're going to use and what you're going to do in the event of a tie or a pickle of some kind. Just agree ahead of time and then stick with whatever methods you agreed on. Okay, so back to plurality with elimination. All right, we have a preference table where a city council is choosing some new street names. And there's 3 names to choose from. So the council had to rank, we're doing a ranking, a preference table. The council had to rank their preferences for the names. One of the road names possibly is Drury Road. So we had 4 council members that decided they liked Drury Road the best, and then they liked Florida Avenue second best, and they liked Bolt Place third best. So I'll just use D, F, and B. Then we had 2 town council members that decided they liked Florida first, Bolt second, and Drury third. 2 council members that decided they liked Bolt the best, then Florida second, Drury third, and then 1 council member that liked Bolt first, Drury second, Florida third. So 6, 7, 4, 6, 8, 9 council members. All right. If we look at the first place votes, if we look at those only, Drury had 4 council members that put it in first place. Florida Avenue had 2 council members that put it in first place, while Bolt Place actually had 3 council members, because you had 2 in that third column plus 1 in the fourth column. Out of 9, all right, so Drury does have plurality because it has the most votes. But remember, with plurality with elimination, we need the majority. We need more than 4.5 for simple majority. So in other words, we're going to need at least 5 votes, because it has to be over half. If you had 9 votes cast, half of 9 is 4.5. So you're going to need at least 5 people that voted for something first. So what do we do with plurality with elimination? We take the one there that had the fewest votes, which was Florida Avenue. I mean, Florida Avenue, they're everywhere. There's one in Tampa, one in Lakeland. Like, there's too many of them. So we take that one and we eliminate it. It had the fewest first place votes. So we just take it out of our table here. Hence the plurality with elimination. So when we redo our table, we're only going to have first and second place now because everything gets bumped up. 4, 2, 2, 1. So we had DB, BD, BD, BD. So we can clean this up a little bit, actually. Because once we take F out, B got bumped up. Everything got bumped up somewhere. Except on the last column, nothing got bumped up. But still. So it went DB, and then the rest of them went BD, BD. So if we wanted to, we could kind of make this a little cleaner. We could say that 4 people voted for DB, and then we could say 2, 4, 5 people voted for BD. Like that. That cleans it up a little bit. 2 plus 2 plus 1 is 5. All right, so now for first place votes, D has 4, B has 5. And remember, we needed more than 4.5 for a simple majority. So B has it. B has 5. So B is the winner by plurality with elimination. So you go through, you tally up those first place votes, or you might just take one vote and tally them up. If somebody has the majority, they win. If nobody has a majority, you might have to do another election until somebody does. Or in this case, we took the fewest votes, F, and Florida Avenue, and tossed it. And then reevaluated the situation. When we reevaluated with F gone, B, or Bolt Place, came in first place. So this new road will be called bold place. And that's it. So we're done. Now, if we hadn't gotten the majority, we would do the process again. We would have eliminated the lowest number of votes, retallied, and you just keep repeating the process until somebody has the majority. All right. And then I think this is the last method, pairwise comparison method. This is another ranking situation, but it's different from board account. Each candidate is paired up with another and compared. When you look at the pairs of candidates, if there's one candidate that was preferred over another more often, that candidate gets a point. If they both are preferred over each other equal amounts of time, each one gets half a point. The winner is the candidate with the most points in the end. Okay, so when you're pairing them up, if you're curious if you got enough pairs, the number of comparisons needed is determined by this formula. However many candidates you have times one less divided by 2 will tell you how many comparisons you need. All right, so let's look at let me leave that formula kind of there. Let's do another preference table where we have a first, second, and third place choices. And for this voting situation, there were 5. So whatever's going, okay, the situation was people are trying to vote on what kind of food to go out to eat in a restaurant. This is pre-COVID-19, so people weren't worried about that. In this group, there's 5 people that ranked their preferences of restaurants: Chinese, Italian, and then Mexican. There were 4 people that ranked their choices Chinese, Mexican, and Italian. 4 people that said Italian, Chinese, Mexican. 5 people that said Italian, Mexican, Chinese. This is making me hungry. 3 people that said Mexican, Chinese, Italian. That's one thing I could say for living here in South Florida now is that hearing these 3 types of food sounds so different, but yet it's not uncommon to find restaurants that have like a whole bunch of different types of foods. It's a lot of diners have like Greek and Italian and American together. But anyways, okay. So 6 had Mexican, Italian, and Chinese. All right, so there's 3 restaurants they're choosing from between the Chinese, the Italian, and the Mexican. So the number of candidates is 3. So the number of pairs that we have to make would be the number of candidates, 3, times 1 less than that, which is 2, divided by 2. 3 times 2 is 6, divided by 2 is 3. So we have 3 pairings that we need to do to check out on this and see what's going on. See what restaurant everyone's going to agree to eat at. All right. So we have to pair up Chinese versus Italian. We have to pair up Chinese versus Mexican. And we have to pair up Italian versus Mexican. I don't need to reverse the order because, Italian versus Mexican is the same as Mexican versus Italian. And that's it. That's the 3 pairings I have to look at. There's no others. C and I, C and M, I and M. All right, so we look at them, and like for C versus I, we go through and count up how often did voters rank Chinese above Italian. Well, like in that first column, Chinese came in first, Italian came in second. So right there, Chinese is above Italian. In the second column, Chinese is in first, Italian's in third. So again, Chinese is above Italian. But in the fourth column, Italian came in first, while Chinese came in second. So there, Italian is above Chinese. So we're going through and we're counting up how often one outranked the other. And don't forget that you have to look at those numbers across the top because that's how many votes essentially outranked them. So let me go through and look at Chinese above Italian first. In the first column, there's 5 that put Chinese above Italian. Second column, there's 4. That makes 9. Third and fourth columns did not do that. Fifth column is another 3, so that's 12. Sixth column did not do that. So there's 12 total voters that decided to say they like Chinese, prefer Chinese over Italian. And then when you go the other direction and look at Italian over Chinese, well, you have 4 in that third column that had Italian above Chinese, 5 in the fourth column, and then 6 in that last column. So that's 15 total that had Italian ranked above Chinese. I should probably do a little quick note over here. How many voters are there? There are 27 voters. And you'll notice that, I'm doing these little rankings, my numbers should add up to 27. I had 12 that prefer Chinese over Italian, 15 that preferred Italian over Chinese. 12 plus 15 is 27. But in this comparison, Italian wins. So let's do our points. So Italian gets a point. All right, next we'll do Chinese versus Mexican. All right, first, second, third columns, Chinese ranked above Mexican. So that was 13. In the fourth, fifth, and sixth columns, Mexican was above Chinese. That's 14. 13 and 14 do add up to 27. Here, Mexican is the winner. Mexican gets a point. Then Italian versus Mexican. We have 5 plus 4 is 9, plus another 5 is 14. So we have 14 where Italian was ranked above Mexican. So that means we should have 13 where Mexican's ranked above Italian. 4 plus 3 is 7, plus 6 is 13. Yeah. So in that one, Italian wins a point. And that's all of our pairings. So Chinese got 0 points in this case. And since Italian has the most points, I guess this group's going out for Italian. Italian wins. That sounds so good right now. Curse my reflux. I have to avoid red sauce sometimes too much. Meatballs and spaghetti sounds so good right now. Okay. Anyways. But that's how you do pairwise comparison. You go through and you pair them up and then see how often one outranks the other. Whoever outranks its partner the most wins a point. And then whoever has the most points at the end wins. Win, win, win. All right. I was just glancing over my math. Okay. So this method is also called the Condorcet method. So there's another one of your mathematicians. Marquis de Condorcet. French gentleman, had significant influence on scientific and political thought during the American and French revolutions. Discovered that sometimes there is no clear way to choose a winner in elections. So that is something that we've got to talk about later. Unfortunately, he was arrested due to politics when Robespierre's Jacobins seized power there in France. He was arrested and died soon after in prison. French prisons at that time were horrid places. So we lost a good mind too early because of politics, but that's his story. So definitely make sure he's on your mathematician list. And then I mentioned tie breaking earlier. There's all kinds of tie breaking methods. If you want to be fair, decide on how you're going to break a tie before your voting begins. It's up to you. But decide on your systems before you begin and then just stick to it as you move forward. Some people say, well, if there's a tie, let's flip a coin, or if there's a tie, let's use another voting method to try to retally the votes, or if there's a tie, let's bring in more voters, see what happens. There's all kinds of methods. But there you have it. All right, so that's 4 very popular voting methods. You're probably familiar with at least one of them before this began, and now hopefully you're getting familiar with all 4. As we move forward, we will get into some of the flaws of these voting methods, and then I'm going to also do a talk on some other voting methods to help you see a little bit more about how things work in the U.S. system and other systems too. But there you go. Well, thank you for joining me, and look forward to doing some more voting math with you soon.